Next is convolution property. Sorry. So we have to explain the convolution property, that is state and proof. First we write down the statement for this. So if x of t, its Laplace transform is x's ROC R1, and h of t, its Laplace transform is hs and ROC R2. Then x1 of t into h of t, its Laplace transform is x of s into hs, and ROC is intersection of R1 and R2. So proof for this is so from the definition of convolution, we can write y of t is equal to integration minus infinity to infinity x of tau h of t minus tau d tau. So we take the Laplace transform, taking Laplace transform on both sides. So we write here y is equal to integration minus infinity to infinity minus infinity to infinity into e raised to minus st dt. So here we are changing the order of integration and noting the fact that x of tau does not depend on t. So changing, we write here, changing the order of integration and noting the fact that x of tau does not depend on t. So we can write here equation as y of s is minus infinity to infinity x of tau integration minus infinity to infinity h of t minus tau e raised to minus st dt d tau. So second integration indicates Laplace transform of so we can write y of s is equal to minus infinity to infinity x of tau into Laplace of h of t minus tau d tau. Now if h of t, its Laplace is hs, then from shifting property h of t minus t0 Laplace of e raised to minus st0 hs. Therefore h of it is e raised to minus s tau into hs. So we can write minus infinity to infinity x of tau hs is constant. So ROC at least, so it is proven. Now what is the meaning of this property? So the convolution of two signals in time domain becomes a simple multiplication process in the transform domain. So we know that the time domain response of LTI system means the convolution of input signal and its impulse response. Thus to find the response of LTI system it is always better to go in Laplace domain than the time domain. So the next property is time integration integration, or we can say integration in time domain. So first we write down the statement for this. Now if x of t, its Laplace transform is x of s ROC R, then integration minus infinity to t x of tau d tau, its Laplace transform x of s by s. So ROC mod of, sorry, not mod, in bracket sigma greater than 0. Now here this symbol indicates intersection. This symbol indicates intersection. Now next is proof. So the proof of this is, here we consider a signal x of t and unit step u of t. So according to definition of convolution, x of t into u of t is equal to minus infinity to infinity x of tau u of t minus tau d tau. So the RHS here, RHS indicate multiplication of the signal. We write here RHS indicates multiplication of signal x of tau by u of t minus tau. So here u of t minus tau indicates delayed unit step. So it is defined as u of t minus tau is 1 for t greater than tau, that is, and this value is 0 for all other values. Okay. Now the value of u of the value of t minus tau is 1, that is the range is 1, and its range is it is less than equal to 1. That means here range of integration is from minus infinity to t. So we take here, write here x of t convolution u of t integration minus infinity to t x of tau d tau. Okay, now we take the Laplace transform on both sides. We write here take Laplace transform on both sides. So Laplace of x of t u of t Laplace of integration minus infinity to t x of tau d tau. Now using convolution property we can write here using convolution property we can write LHS term as Laplace of x of t into Laplace of u of t minus infinity to t x of tau d tau. Therefore x of s into 1 by s plus or integration minus infinity to t therefore Laplace of So in this way we can prove it. Now the meaning of this time integration property is that The integral of time domain signal corresponds to the division by S in Laplace domain. Integral of time domain signal corresponds to division by S in Laplace domain. Now next property is integration in S domain. Or we can say division by t. So first we write down the statement here. If x of t, its Laplace transform is xs, then x of t by t, its Laplace transform is integration s to infinity xs into ds. So ROC or R. Now next is proof for this. According to definition, of Laplace transform, xs is minus infinity to infinity x of t raised to minus st dt. Now integrating both sides, from s to infinity. So we can write s to infinity xs into ds, s to infinity and x of t into e raised to minus st dt into ds. So changing the order of integration, of RHS, we get s to infinity x of s ds minus infinity to infinity x of t s to infinity e raised to minus st ds dt. So we solve it. It is s to infinity xs into ds. It is minus infinity to infinity x of t e raised to minus st by minus t s to infinity dt. So it is minus infinity to infinity x of t into So but what is the value of e raised to minus infinity? It means 1 by infinity, so its value is 0. So above equation becomes s to infinity. I write this on next page. So above equation becomes s to infinity xs into ds equal to minus infinity to infinity x of t by t e raised to minus st dt. Now we are comparing the RHS with the definition of Laplace transform. We write here comparing RHS with definition of Laplace transform. So s to infinity xs ds Laplace of x of t by t, and we can write x of t by t, its Laplace transform is integration s to infinity xs into ds ROC R. So this is integration in s domain or division by t property. Now what is the meaning of this integration in s domain? If the Laplace transform of the function x of t exists, then the integral of corresponding transform with respect to s in the complex frequency domain will correspond to division by t in the time domain. Next is conjugation property. So we have to just state this property, only statement, no proof. So if x of t, its Laplace transform is xs, then conjugate is represented by this symbol, that is x of conjugate of x of t, its Laplace transform is conjugate of x of s conjugate. So here this sign indicates complex conjugate operation. So up till now we have seen the different properties of Laplace transform, like linear property, time shifting, shifting in s domain, time scaling, differentiation in time domain, differentiation in s domain, convolution, integration in time domain, integration in s domain, and conjugation. Conjugation. We have seen the proof and statement of all these properties. So So